Building an engine always starts with the engine block. A technician carefully loads the 3.6-liter aluminum block onto a fixture that Romulus calls a pedestal. Once it's securely in place, she scans a two-dimensional matrix tag, creating an identification number for the engine that it will carry through production. A team member loads a crank onto a fixture, where a scanner reads a two-dimensional matrix before he pushes the crank into an oiling mechanism. When the mechanism is finished oiling, the technician removes the crank and uses a lift assist to transfer it to the engine block with the help of a guide for proper axial location. The pistons are counterbalanced for either one side of the engine or the other. A technician unloads a set of 3. He puts a piston guide fork inside a bore and then aligns a conrod on the other side. A semi-automatic piston stuffer installs the piston. He removes the fork, then installs the conrod cap. An initial torque keeps the piston in place. He lines up the crankshaft for installation of the next cylinder. At the next station, a fully automated operation begins with a mechanism lifting the engine off its pedestal. Cameras check under the block for type, orientation, and error-proofing of the pistons. Automatic fasteners then run down the bolts, giving them their final specified torque. The mechanism lowers the block back onto its pedestal. A team member installs a component called the oil deflector plate. She lowers a semi-automatic hand-applied multi-spindle gun into position with the help of 2 spring-loaded locator pins. Fully torque-controlled and angle-monitored, the spindle gun runs down all the bolts at once. The technician rotates the engine to align it so she can easily install the oil pump. She starts the bolts manually to ensure there's no risk of cross-threading when they're tightened. Next, a technician uses a lift assist to move the Camaro's dual overhead cam cylinder head and cam carrier to the engine and lower it into place. The cylinder head drops down onto a gasket previously installed and retained by dowel pins. A high-tech device now applies a plasma treatment to the engine's front cover. The plasma treatment simultaneously cleans and electrically charges the surface for better adherence to a specialized sealant. The RTV, or room temperature vulcanization sealant, goes on the surfaces next before a technician installs the cover. A team member installs the cam cover. Once it's in place, he manually starts the bolts to prepare them for final fastening at the next station. Once the engine slides into position, a multi-spindle mechanism descends. There are 18 bolts on the cam cover and 18 spindles on the machine. It torques the cover on in one shot. As with every other component on the engine, GM technicians have scanned the cam cover and added its information to the engine's data.